The radius of the base of a cone is decreasing at a rate of 2 centimeters per minute. So this tells us that of that cone, dr dt is -2. The height of the cone is fixed at 9 centimeters, so h equals 9. At a certain instant, the radius is 13 centimeters. What is the rate of change of the volume of the cone at that instant? So we're looking for dv dt. So if we're looking for dv dt, we should start with the formula for the volume of a cone, which is pi over 3 times r squared h. I'm going to differentiate this implicitly with respect to time. Dv dt equals pi over 3, that's a constant, multiplied by the derivative of r squared h, which I will have to use product rule while differentiating implicitly. That's 2r times dr dt h plus r squared times dh dt. So now I need to plug in what I know. I'm solving for dv dt, and that's going to be pi over 3 times 2 times r, which is 13, times dh dt, times dr dt, which is -2, times h, which is 9, plus r squared, which is 13 squared, times dh dt. Now what is dh dt? Well, they tell us that the height of the cone is fixed. So that means that the height of the cone never changes. So dh dt is 0. So this term here is gone. So dv dt is going to be pi over 3 times -468, which is going to be -156 pi, and the units will be change in volume, centimeters cubed, over change in time, minutes.